Hi everyone, today we are going to go through factoring using decomposition. So things to remember with this. When we are factoring, we are solving in a quadratic equation. So the question might say solve for x, or determine the x-intercepts, or find the zeros. In all of those cases, you would use factoring to solve the equation. And we are going to go through the way that always works, which is decomposition. So things we need to remember, always common factor first, and that there are shortcuts. So decomposition will always work, but there are shortcuts that are quicker, and we will be going through some of those shortcuts in a future video. So let's go through some examples. Example number 1. So let's say we have this as our quadratic equation. So 2x squared plus 3x plus 1 equals 0. And we want to solve this. So that means that we want to find the values of x that would make this equation equal to 0. So make the left side equal to the right side. So what we want to do first is we look and we say we want to look at our first term, which is 2, and our last term, which is 1. So our a value and our c value, and we multiply those two things together. So we've got 2 times 1, which is 2. So when we're doing the process of decomposition, we're looking for two numbers that multiplied to 2 also have to add to our middle term. So it has to add to 3. So this is a simple one. Numbers that multiply to 2, our only options are 1 and 2. And those two numbers also add to 3. So we're going to take those two numbers and we're going to break down that middle term. So it will look like this. 2x squared plus x plus 2x plus 1 equals 0. So this 3x has been broken down into x plus 2x. Now, the next step is that we want to common factor 2 times. So we look at our first two terms and our last two terms, and we're going to try to figure out what is common with both. So looking at our first two terms, we have got 2x squared plus x. So I can factor an x out of both of those terms. So 2x squared divided by x is 2x. And x divided by x is just 1. So it'll be 2x plus 1 in that bracket. Now, the second two terms, we've got 2x plus 1. Now, there's nothing that's common to both except for 1. And to kind of keep the pattern going so that it always works, we're going to say that we're going to factor out a positive 1. So if I factor out positive 1, I'm left with 2x plus 1. And this all is still equal to 0. Now I'm going to common factor one more time. I'm going to look at all my terms and I'm going to say the brackets are the same. So I'm going to factor out a bracket, all right? And what's left over will go in the other bracket. So if I remove the 2x plus 1, it's the x that's left over. And here in my second term, if I remove that 2x plus 1, I have a plus 1 left over. And that's equal to 0. Now, if you were asked to solve this, you would say that therefore x is going to be equal to negative 1/2, or x is going to be equal to negative 1. But we'll look at solving the zeros or finding the zeros in another video. Now, one thing I wanted to note is that the order of your x terms, that doesn't matter. So if we look up here, we put x first and then the 2x. Let's do it the other way. So we would have 2x squared plus 2x plus x plus 1 equals 0. So if I rearrange those middle terms, I will end up with the exact same answer, but let's go through it. So for these first two terms, I'm going to factor out a 2x, and I'm going to be left with x plus 1. For my last two terms, I come up with the same situation where I am missing, where I can only factor out a 1. And I'm going to be left with x plus 1. And then if I look to see what's common, I have x plus 1. And what's left over is 2x plus 1. All right, and you can see that my brackets are exactly the same as they were above, just the other way. So 2x plus 1 times x plus 1, or the other way around, x plus 1 times 2x plus 1. All right, let's do another example. Let's say that we have an example like this one. 6x squared plus 8x minus 8 is equal to 0. The first thing that we should notice is that all of our terms are even. So that means I can factor out a 2. This is where that common factoring first always applies. So I'm going to factor out a 2 first, and I'll be left with 3x squared plus 4x minus 4 is equal to 0. So now I'm going to do decomposition within those brackets. So I'm going to take my A value and my C value. Here my C value is negative, so I need to find two numbers that are going to multiply to negative 12 and add to positive 4. Now, you might be able to come up with these numbers right off the top of your head, but if you can't, that's okay. Start by writing down everything that multiplies to 12. So 1 and 12, 2 and 6, 3 and 4. Now, we know that it's multiplying to negative 12, so that means that one of our numbers are going to have to be negative. So there's no way for 1 and 12 to add up to 4. There's no way for 3 and 4 to add up to 4. So 2 and 6 is the one we want to look at. Now, if the negative is on the 2, that would add up to positive 4. But if we were switching it, if we had a different question, if the negative was on the 6, it would add up to negative 4. So negative 2 and positive 6 are the numbers that we want to work with. So we're going to add that into our question. So 3x squared minus 2x plus 6x minus 4 is equal to 0. Okay, so now inside my brackets is where I'm going to factor. So I'm going to leave those big square brackets, and I'm going to common factor my first two terms. So what's common to those two terms is an x. So I have 3x minus 2. Now if I common factor my last two terms, I can factor out a 2 here. So plus 2, and I'm left with 3x minus 2. I'm going to close those square brackets. Now, I should say that whenever you're doing decomposition, your brackets, when you do your common factoring of your first two and your last two terms, should be the same. If they're not the same, go back up, check the numbers that you split that middle term into, because you might have made a little mistake there. So now, So now I'm going to look at what's common inside my bracket. So the 3x minus 2, that bracket is common. And if I factor out that bracket, I'm left with x plus 2. Okay, so that'd be this is an example of decomposition where you have to factor out a common factor first. Now, let's look at an example of a simple trinomial. We'll be looking at the shortcut in a little bit, but the decomposition will still work here. So what we need to remember is that there's kind of that imaginary 1 out in front of my x squared term. So when I'm looking for what to multiply to, I'm going to say that it has to multiply to 6. So 1 times 6 is 6. And it has to add, in this case, it has to add to negative 5. So let's take a look. Our options are 1 and 6 and 2 and 3. It has to multiply to positive 6 and add to negative 5. So things like this can be tricky. Now, if it has to multiply to a positive number, we know that both of our terms are going to have to be negative. So negative 1 and negative 6 don't add up to negative 5. They add up to negative 7. So our number is going to be negative 2 and negative 3. So that is one of those questions where you kind of have to double check your signs. So let's plug this in. So we have x squared, and instead of writing negative 5x, we're going to write that as negative 2x minus 3x plus 6 is equal to 0. And the steps are all the same. I'm going to common factor twice. So my first two terms, what's common is an x. So I have x minus 2. And if I look at my last two terms, I can factor out a negative 3. So I have x minus 2 left over. And then again, if I factor again, I can see that my bracket is what's common, x minus 2. And then I have x minus 3 left over. Okay. Now, when I'm doing a decomposition with a simple trinomial, note that the numbers that I originally picked were negative 2 and negative 3. those are the same numbers here. So this is kind of where our shortcut will come into play, but we'll look at that at another date. All right. If you have any questions, please message me below. Thanks.